At 8:40 in the morning, Mountain Time, the National Weather Service issued a blizzard warning along Interstate 80 in Wyoming. 3 hours later, in Boston, the same agency wrote that temperatures at 850 millibars on Tuesday would be 2 to 3 standard deviations above the operational climate record, close to the maximum relative to climatology for this time of year. A blizzard warning and an all-time May heat record forecast. Same agency, same calendar day. 404 active alerts across the country. 5 simultaneous categorical extremes. Every single one of them driven by a single Rossby wave that has amplified into a configuration the climate models said should not be this common this early in the year. Social media is calling it convergence. The peer-reviewed literature has a different name. We are going to walk through what the wave actually is, why it is producing snow and record heat on the same morning, what loaded the gun over the past several months, and why this kind of day is going to keep happening, including the part almost nobody is talking about. Part 1. The day. The atmosphere refused to pick a season. At 8:40 Mountain Time on Monday, May 18, 2026, the National Weather Service office in Cheyenne issued a blizzard warning for the North Snowy Range foothills along Interstate 80, covering Arlington and Elk Mountain. The text is short and operational. Blizzard conditions currently occurring, winds gusting to 50 miles per hour, visibilities dropping below a quarter mile due to falling and blowing snow. Severity classification, extreme. That is the highest urgency tier the National Weather Service uses for winter storm products. Wyoming has 31 active alerts today, highest of any state in the lower 48 outside of marine zones. 3 hours earlier, at 5:32 Mountain Time, Denver forecasters were analyzing the same upper trough. East-facing slopes north of Interstate 70 in the mountains, 12 to 18 inches of snow. Rocky Mountain National Park, the Snowy Range, the North Laramie Range, the Sierra Madre, the Ferris, Sano and Shirley Mountains, all upgraded to winter storm warnings simultaneously. At 7:30 Eastern, while Wyoming snow was already falling, the Boston office was writing its morning area forecast discussion. Key message at the top: increasing confidence of record heat Tuesday for parts of southern New England. Then, further down, the sentence this entire video turns on. 850 millibar temps are 2 to 3 standard deviations above normal, which is close to the maximum relative to the CFSR climatology for this time of year, suggesting very anomalous heat. Pause on that. A National Weather Service forecaster, professional, cautious by training, just described the temperature at 5,000 feet of atmosphere as approaching the maximum in the modern observational record for this calendar date. The CFSR archive goes back to January 1st, 1979. That is 46 years. In the most measured technical language the agency uses, Boston told its forecast audience that what is about to happen on Tuesday is approaching the worst-case scenario in the entire modern record for this date. And on the same morning, a blizzard warning in Wyoming, a moderate tornado risk over Kansas and Nebraska, an extreme fire weather designation over the southern high plains, extreme being the highest non-emergency tier the Storm Prediction Center issues, a moderate flash flood risk over central Missouri, 5 categorical operational extremes, same 24 hours, same Rossby wave. The full count of 404 active alerts includes 1 blizzard warning, 12 winter storm warnings, 19 winter weather advisories, 7 freeze warnings, 15 red flag warnings, 1 heat advisory with more building through the afternoon, 21 flood warnings, 10 flood watches, 3 severe thunderstorm warnings, 6 severe thunderstorm watches, 16 wind advisories, 19 gale warnings, and 27 air quality alerts. Every season of the year is represented in those products: winter, severe weather, fire, flood, heat, marine. the National Weather Service has run out of seasons to issue products against. Here is what is uncomfortable about putting all of that in the same paragraph. There are no surprises in any individual piece. A moderate severe weather day in mid-May in Kansas is not strange. A late-season snow event in the high Wyoming mountains is unusual, but not unheard of. An early heat wave on the East Coast happens roughly once a decade. Fire weather in the Texas Panhandle after a drought year is normal. Flash flooding in Missouri after weeks of saturated soils is consistent. Each story on its own would barely make a national broadcast. The story is the simultaneity. The story is that they are all happening at once, driven by one configuration on one calendar date. And the office that has written that down most carefully, in the most technical language, with the least editorial heat, is Boston. Because Boston is the one looking at numbers close to the maximum in 46 years of data. Part 2. The Boston 850 Anomaly. The Climate Forecast System Reanalysis, CFSR, is the operational climate dataset the National Weather Service uses as its baseline for atmospheric anomalies. It covers January 1st, 1979 to present, continuous. 46 years of gridded data for temperature, wind, humidity, and dozens of other variables at standard pressure levels from the surface to the top of the atmosphere. The pressure level that matters for what Boston is forecasting Tuesday is 850 millibars. That is approximately 5,000 feet above sea level, the temperature of the lower troposphere, the part of the atmosphere that mixes down to the surface during the day when the sun heats the ground. When the Boston forecaster writes 2 to 3 standard deviations above CFSR climatology for this date, he is taking the model output for Tuesday, comparing the forecast 850 temperature to the distribution of every 850 temperature recorded for this calendar date across 46 years and reporting the standardized departure. 2 standard deviations above the mean, roughly the top 2.5% of all observations in the historical record. 3 standard deviations, roughly the top 1/8 of 1%, about 1 in 750 observations. In a 46-year record, 3 sigma events happen on the order of once a decade, sometimes less. The detail that pushes this past statistical curiosity is what Boston wrote after the number. Close to the maximum relative to CFSR climatology for this time of year. That is not a rhetorical flourish. That is the operational interpretation. The value is approaching the highest the reanalysis has ever recorded for this date in southern New England. Forecasters do not write that lightly. What does an 850 temperature of 18 to 20 degrees Celsius actually mean at the ground? 18 Celsius is 64.4 Fahrenheit. 20 is 68. That is the air mass arriving over southern New England Tuesday afternoon. When that air mass mixes down to the surface, it warms adiabatically as it descends, roughly 10 degrees Celsius per kilometre of descent, or about 5.5 Fahrenheit per 1,000 feet. From 5,000 feet down to the surface, approximately 27 degrees Fahrenheit of warming. Add that to a 64 to 68 degrees starting point at altitude, and you get surface temperatures in the lower 90s at the cool end, approaching the lower hundreds at the warm end. Boston puts the actual forecast at mid-90s away from the south coast, with potential upper 90s in the Connecticut River Valley. The 925 millibar level, about 2,500 feet, is even more diagnostic. Forecast for Tuesday, 24 to 26 Celsius, 75 to 79 Fahrenheit at 2,500 feet. Mix that to the surface and you get mid to upper 90s without much further warming required. Both pressure levels tell the same story. The lower troposphere is hot, the boundary layer will be hot, the mixing will be efficient because the air is dry. The Mount Holly office in New Jersey framed Tuesday similarly. Unusual and potentially record-setting early season heat, with highs 10 to 20 degrees above normal, Then this sentence, worth pulling out for what it tells us about the public health side. Not terribly humid, but certainly uncomfortable since we aren't acclimated to it yet. There is a clinical reason that early season heat events are operationally dangerous in ways that midsummer events are not. The human body acclimates to heat over 10 to 14 days of repeated exposure. Sweat rates increase. Sweat composition changes to conserve electrolytes. Plasma volume expands. Cardiovascular capacity adapts to handle higher skin blood flow. None of those adaptations have occurred in southern New England or the New York metro area, because the region was in the 60s and 70s until this past weekend. The first heat event of the season kills more people per degree of departure from normal than the 7th or 8th event. The acclimatization curve takes 10 to 14 days. There have not been 10 to 14 days. There has been the weekend. The National Weather Service Heat Risk Scale rates Tuesday over the Mid-Atlantic and southern New England at major, the third tier from the bottom, reserved for events with elevated mortality potential, especially for sensitive populations and unacclimated people. Major heat risk in May in the northeast is operationally early. Historically, it clusters from late June through August. It happens in this region every 5 to 10 years on average. Tomorrow is one of those rare days, and the hospitals know it. The cooling centres are staffing up. Emergency management agencies are pre-positioning. Here is the part most people watching local television tonight will not hear. Boston is the office writing close to the maximum relative to 46 years of operational data. The wave producing that number is the same wave that put a blizzard warning over Interstate 80 in Wyoming this morning. That is not a coincidence. That is a mechanical consequence of the same piece of atmospheric physics operating on opposite ends of a wave locked in high amplitude, low phase speed resonance. Which means the rest of this story is not the East Coast heat. It is Wyoming. Part 3. The Wyoming side. The North Snowy Range foothills stretch along Interstate 80 between Arlington and Elk Mountain in south-central Wyoming. Elevation along that stretch runs between 6,500 and 8,000 feet. The road climbs over a pass that has been the site of more lethal winter storm crashes over the last 50 years than almost any other stretch of interstate in the United States. The locals call it the Snowy Range Corridor. The Wyoming Department of Transportation closes it an average of 50 to 70 days a year. It is closed today. Behind the blizzard warning sit 5 separate winter storm warnings from the same office for the same date. Sierra Madre Range, 8 to 16 inches, gusts to 50 miles per hour. Snowy Range and North Laramie Range, 10 to 20 inches with locally higher amounts above 8,500 feet. The Ferris, Sano and Shirley Mountains, 6 to 12 inches, gusts to 45 miles per hour. Central Carbon County, 5 to 10 inches. South Laramie Range, 7 to 14 inches. 1 blizzard warning. 5 winter storm warnings stacked behind it. All from a single office, all on one date. The operational criteria for a blizzard warning: sustained winds or frequent gusts at 35 miles per hour or greater, snow reducing visibility below a quarter mile, those conditions continuing for at least 3 consecutive hours. The North Snowy Range Foothills event meets all 3. Winds gusting to 50, visibility collapsing in falling and blowing snow. Conditions continuous through the morning into the afternoon. By definition, this is a blizzard. Issued in mid-May, in the lower 48. Mid-May blizzard warnings in the lower 48 are not unprecedented, but they are events that long-term residents remember. They happen when a deep upper trough that should have been gone weeks ago dives back into the Great Basin and the Central Rockies and runs cold air down its backside, while the eastern half of the continent heats up. That is exactly what is happening today. The Denver Boulder office spelled out the mechanism. The trough moving across the state with favourable mid-level ascent, upslope flow at the surface, wind blowing east to west into the rising terrain of the Front Range. Air forced upward cools adiabatically about 10 degrees Celsius per kilometre of lift. As it cools, it reaches saturation. As it saturates, it precipitates. If the temperature at the precipitation level is below freezing, it precipitates as snow. The east-facing slopes of the Front Range and the Medicine Bow Range are forced uplift zones in this configuration. When the trough is deep enough and the upslope flow is moist enough, you get the accumulations we are seeing today. The Sierra Madre component deserves a separate mention. 8 to 16 inches of snow accumulation on the eastern side in the third week of May is a lot. The climatology for May, averaged across the period of record, has these mountains receiving roughly 2 to 4 inches for the entire month. Today they are getting 8 to 16 in a single 12-hour event. The North Laramie Range, whose May average is around 6 to 8 inches for the whole month, is getting 10 to 20. The Medicine Bow Range, 12 to 18. This kind of snow event at this point in the calendar sets up secondary effects that do not appear on the alert page. The snow line drops to about 7,500 feet during the heaviest precipitation. Below that line, cold rain saturating already saturated ground. The spring runoff timing, which was already running ahead of climatology this year because of a warm April, just got reset. Late-season heavy wet snow on top of already melting snowpack can produce abrupt secondary runoff pulses when it melts. Crews are watching the Cache La Poudre and North Platte drainages for what happens over the next 48 hours. Cheyenne is forecast to drop to the upper 20s to low 30s tonight, Casper into the mid-20s. The state is in winter on the morning of May 18th. And here is the part to fix in your head before moving on. The trough digging into Wyoming and producing the blizzard is the same trough ejecting energy out of the Rockies and into the Central Plains, producing the moderate-risk tornado outbreak in Kansas and Nebraska. The trough is the western half of a single Rossby wave running from the Pacific Northwest all the way across the continent to the western Atlantic. The eastern half of that wave is the ridge anchoring the Bermuda High offshore the east coast. The eastern half is what is making Boston's 850 temperature 2 to 3 sigma above 46 years of data. The Wyoming blizzard and the New England heat dome are not separate stories. They are two faces of one configuration. Part 4. One wave, two faces. A Rossby wave is a planetary scale undulation in the mid-latitude westerly winds. Named after Swedish-American meteorologist Carl Gustaf Rossby, who described their basic dynamics in a paper published in 1939. The mechanism. The Coriolis effect combined with the temperature gradient between the equator and the pole. Warm air over the equator rises, cold air over the pole sinks. Air gets transported between the two reservoirs to keep the system balanced, deflected by Earth's rotation into the west to east band of winds between roughly 30 and 60 degrees latitude. That band is not straight, it undulates. The undulations are Rossby waves. Wavelengths range from 3,000 to 6,000 kilometers. Amplitudes range from a few hundred kilometers in their quiet state to a couple thousand in their amplified state. Phase speed, the rate at which the entire wave pattern moves east, is typically around 15 degrees of longitude per day in normal conditions. In their normal state, Rossby waves do their job quietly. They mix warm and cold air. They produce day-to-day weather. They keep cold polar air bottled up at higher latitudes most of the time. Then sometimes they stop being modest. The dips dig farther south. The bulges build farther north. The phase speed slows to 5 degrees per day, to 3, to near 0. The wave locks in. The same regions sit under the same troughs and ridges for days at a time. And the consequences are what we are watching this morning. The technical name for this in the recent climate literature is quasi-resonant amplification. The concept comes from a 2013 paper by Vladimir Petukov and colleagues in the Proceedings of the National Academy of Sciences. They found that when waves of a specific wavelength get trapped in the middle latitudes, when their natural eastward propagation is interrupted by conditions in the polar jet, they enter a resonance state where they can no longer move and their amplitude grows. The specific wave numbers this happens to, 6, 7, and 8. 6 full ridge-trough cycles around the hemisphere. 7, 8. When waves are at one of those numbers and the polar jet conditions are right, they get stuck. The Petukov paper was a starting point. The most important follow-up from the perspective of what we are watching today is a 2020 paper in Nature Climate Change by Kai Kornhuber, Daniel Kumu, and a team across several institutions. Title: Amplified Rossby waves enhance risk of concurrent heat waves in major breadbasket regions. They looked at the historical record of concurrent heat extremes in the Northern Hemisphere, events where two or more major agricultural regions experience extreme heat simultaneously, separated by thousands of kilometers, while the rest of the hemisphere sits near normal. They found that when the planetary wave is at wave number 5 or wave number 7, the probability of concurrent extremes increased by up to a factor of 20. Not a typo, 20 times more likely. The cascading effects on crop yields, roughly a 4% average global reduction in major crop production, with regional reductions of up to 11% during the worst wave number 5 and wave number 7 years. The dynamical mechanism Kornhuber described is the same one operating today. When the wave locks into high-amplitude, low-phase speed configuration, regions under persistent ridges experience persistent high pressure. Persistent high pressure means descending air. Descending air means clear skies, low humidity, and strong solar heating. After 3 or 4 days of that, the surface is hot. After 5 or 6 days, very hot. After a week, records fall. And the configuration does not break by itself. The current configuration matches the wave number 5 to wave number 7 signature Kornhuber identified as the highest risk pattern for concurrent extremes. The wave is locked, phase speed is low, amplitude is high, trough over the Great Basin, ridge over the Western Atlantic. The pattern around the hemisphere, roughly 5 to 7 stationary highs and lows, that is the resonance signature, and it is what is producing the Wyoming blizzard and the New England heat dome simultaneously. Then there is the part of the literature that is harder to talk about, the part that says these patterns are happening more often than climate models predicted. A 2023 follow-up paper by Kornhuber and others in Nature Communications. Risks of synchronized low yields are underestimated in climate and crop model projections. The argument: the CMIP6 model suite, the current generation used in IPCC assessments, does not adequately reproduce the resonance behavior producing these concurrent extremes. The models have structural biases. They are slightly too zonal, too west to east, and do not amplify the waves enough. When you compare model output to observations over recent decades, the observations show more amplification and more synchronized extremes than the models predicted. The implication: we are probably underestimating the future frequency and intensity of days like today. The models say events like this should happen every 10 to 15 years. The observations of the last decade say closer to every 3 to 5 years. The direction is settled. The models are under-predicting. Part 5. How the drought loaded the gun. The first precondition is what we covered in the video from May 12th. The worst spring drought in the modern instrumental record for the United States. The National Centers for Environmental Information dataset goes back to 1895. 131 years of operational climate observation. The January through April 2026 period was the second driest in that entire record, behind only 1910. The Palmer Drought Severity Index for March 2026, negative 7.85. The April value, negative 7.56. The only months in the entire record with lower PDSI values are July and August of 1934, the bottom of the Dust Bowl. 43.5% of the lower 48 in D2 drought or worse by late April, the largest footprint since August 2012. This is the loaded gun. The dry land surface across more than half the country is the backdrop against which the eastern ridge is building today.
And the reason that matters for the heat dome is a piece of physics that gets a paragraph in atmospheric science textbooks, but almost never makes it into broadcast meteorology. It is called soil moisture-atmosphere coupling. The pathway was quantified in a 2019 paper in PNAS by a team led by Diego Morales at Ghent University. They found that under dry land surface conditions, the likelihood of extreme heat increased by about 30% compared to wet surface conditions, with the largest effect during transition seasons like spring and early summer. The physics is straightforward once you see it. When the sun shines on Earth's surface, the incoming radiation has to go somewhere. The part that gets absorbed has two main pathways out. One is sensible heat. The surface warms and heats the air directly through conduction. The other is latent heat. Water at the surface evaporates, pulling roughly 2.5 megajoules of energy out of the surface per kilogram as it transitions from liquid to vapor. That energy goes into the atmosphere as latent heat in the water vapor, not as temperature in the air. When the surface is wet, most incoming solar energy goes into evaporation. The air stays cooler. When the surface is dry, there is no water to evaporate. All of the incoming energy comes out as sensible heat. The air gets very hot. This is why Dust Bowl summers were so brutal. The Great Plains had no moisture to evaporate. Incoming solar radiation went entirely into heating the air. The Cook, Miller and Seeger paper from 2009 in PNAS quantified this. The Dust Bowl heatwave amplification was substantially driven by the dry land surface, contributing a degree to 1.5 degrees of additional warming above what the synoptic pattern alone would have produced. The same mechanism is amplifying the eastern heat dome today. Soil moisture across the region is in the bottom 10th percentile of historical values for the date. That 30% additional likelihood of extreme heat from Morales' work is part of why Boston is forecasting 2 to 3 sigma 850 millibar anomalies tomorrow. The ridge would have built either way. The dry surface is what is making the temperatures under the ridge as high as they are. The second precondition is more recent, the aerosol unmasking pulse that began in 2020. In January of that year, the International Maritime Organization implemented a new global sulfur cap on marine fuel, the IMO 2020 regulation. Before the regulation, ocean shipping ran on bunker fuel with roughly 3.5% sulfur content. After, the cap dropped to 0.5%. This reduced sulfate aerosol emissions over the global oceans, particularly over North Atlantic shipping lanes, by roughly 1/3 overnight. Sulfate aerosols scatter incoming solar radiation back into space. Remove them, and you remove that cooling. James Hansen and co-authors published a paper in 2023 in Communications, Earth and Environment, quantifying the effect at roughly 0.05 degrees Celsius of additional warming per decade. The paper was controversial. Other groups have debated the numbers. The direction of the effect is not in dispute. The North Atlantic has been running above the modern record baseline for nearly 3 years. A warmer North Atlantic favours a stronger, more westward extended Bermuda High, which is exactly what is sitting off the east coast today, trapping warm air over the region more effectively than it would in a cooler baseline year. The third precondition is the ENSO transition. The Oceanic Niño Index was at negative 0.55 during October, November, December 2025. By February, March, April 2026, positive 0.11. Officially neutral, but warming. The NOAA Climate Prediction Center issued an El Niño watch in May, with an 82% probability of onset by July. Transition states historically favor amplified ridging east of the Mississippi. The spring 2014 transition, the spring 2015 transition, the spring 2023 transition all featured amplified eastern ridging at some point during the window. The Bermuda High is doing today what it tends to do during these transitions: stack the preconditions.
The aerosol unmasking pulse has shifted the radiative forcing balance over the North Atlantic. That has warmed sea surface temperatures. That has strengthened and extended the Bermuda High westward. The ENSO transition has shifted the storm track in ways that favour eastern ridging. The seasonal drought has produced a continental-scale dry land surface. The megadrought baseline, the Williams, Cook and Smerdon 2022 paper in Nature Climate Change, established the 2000 through 2022 period as the driest 22-year stretch in southwestern North America in at least 1,200 years, with 42% of the soil moisture deficit attributed to anthropogenic climate forcing, has depleted the regional moisture reservoirs that would normally dampen short-term events like this one. Each of these alone would not produce today. Together, they produce the conditions in which a single ejecting upper trough can amplify a Rossby wave into the configuration we are looking at. The trigger is the trough. The preconditions are everything that has been happening for months and decades to make the trigger this effective. Part 6. The three other faces. The Plains tornado outbreak is the trough's most visible product from the surface. The Storm Prediction Center issued a Day 1 convective outlook with a moderate risk area covering central and northeast Kansas, southeast Nebraska, and far northwest Missouri. Moderate risk is the fourth tier of the 5-level SPC scale. It is issued on roughly 4 to 6% of all Day 1 outlook days in the historical record, about 20 days per year. Most are in the spring severe weather season. The SPC narrative. Supercells capable of producing very large to giant hail and multiple strong to intense tornadoes, most likely from central Kansas and southeast Nebraska into Iowa and northwest Missouri. Hailstones 2 to 4+ inches in diameter, baseball to softball size. Tornadoes rated E, F2 and above, with wind speeds from 111 to over 160 miles per hour, multiple of them. Population under the moderate risk, around 3 million people. The highest risk window for the strongest tornadoes, 4 in the afternoon to 8 in the evening Central Time. Same trough, same wave. The ejecting shortwave from the trough is what is pulling warm moist air northward from the Gulf, while strong southwesterly flow aloft brings cold air in at mid-levels. The temperature contrast between warm moist air below and cold dry air above is the instability. The Dodge City morning sounding showed mid-level lapse rates of 9 degrees Celsius per kilometre in the 700 to 500 millibar layer, the steepest you typically see during a severe weather setup. That number supports the giant hail forecast. It supports the intense tornado language. It is what the trough produces when it ejects energy into a moist, warm sector. The extreme fire weather is the backside of the same trough, descending, drying air over the southern high plains. Extreme is the highest non-special emergency tier the Storm Prediction Center issues on its Day 1 fire weather outlook. Today, that tier covers the Texas Panhandle, the Oklahoma Panhandle, the eastern third of New Mexico, and the western fringe of Kansas. Air descending off the Rockies warms and dries adiabatically, 10 degrees Celsius of warming per kilometre of descent, with a corresponding drop in relative humidity. The result? Surface air over the Texas Panhandle peaking near 100 degrees Fahrenheit with single-digit relative humidities. The energy release component, the National Fire Danger Rating System metric combining fuel moisture, temperature, humidity and wind into a single fuel state index, is running at the 90th percentile of historical values for the date. 90 percentile means the fuel bed is at a level historically only reached on the very worst fire weather days for this date. The grass and rangeland covering the region is dormant or dying back. The fuel is cured, it is ready to burn. The fires that established the reference class, the Camp Fire of November 2018 under Diablo winds, the Marshall Fire of December 2021 in Boulder County under gusts to 115 miles per hour, the Smokehouse Creek Fire of February 2024
burning over 1 million acres in the Texas Panhandle in a single day, all ignited under conditions less severe than what is in place this afternoon. The conditions are present. Whether anyone ignites into them is the contingency. The Missouri flash flooding is the fourth phase, the warm sector moisture transport on its eastern flank, lifting over the warm front that runs across central Missouri and producing training thunderstorms, each dropping heavy rain over the same corridor on top of soils that have not drained from the previous round. 21 active flood warnings on rivers across the lower Midwest. The Missouri River in flood at multiple gauging stations. Same moisture supply, same wave, different mechanism. Part 7. The Open Loop. The cold front arrives Wednesday afternoon. The eastern ridge weakens, the wave progresses east. The Bermuda High retreats offshore. Amplitude drops back to normal range by Thursday. Northeast temperatures Friday will be 15 to 20 degrees cooler than Tuesday's peak. The pattern is over by the Memorial Day weekend. But that is only this pattern. Kornhuber's 2023 Nature Communications paper made an argument that has not been fully absorbed by the operational forecasting community. The climate models used to project the next 20 years of warm season weather are systematically underestimating the frequency and intensity of resonant Rossby wave configurations like the one driving today's events. When you compare model output to observations over recent decades, the observations show more amplification and more synchronized extremes than the models predicted. The gap between model and observation is narrowing. It is not closing. The models say once every 10 to 15 years. The observations of the last decade say closer to once every 3 to 5 years. What this means for the forecasts running into June, July and August. The configurations that produce concurrent extremes, simultaneous heat dome, drought, fire weather and severe weather days that historically were operationally rare, are very likely to repeat. The Climate Prediction Center summer outlook continues to favor above normal temperatures across most of the country. The El Niño watch is active, with 82% onset probability by July. Once the El Niño signal couples atmospherically, the wave configuration we have today may become a recurring summer feature, rather than a transient mid-May event. And the warning systems were not designed for what comes next. The National Weather Service is built around individual hazard categories: severe weather watches, fire weather outlooks, heat advisories, winter storm warnings, flood warnings. Each category has its own product, its own audience, its own communication pipeline to broadcast meteorology, emergency management, transportation, agriculture, healthcare. The simultaneity of 5 categorical extremes on a single calendar day strains that architecture. The audience under a heat advisory in Boston is not the audience under a blizzard warning in Wyoming. Each office talks to its own region. Nobody is talking about the wave doing all of it. The atmosphere is doing one thing. The warning system is communicating it as 5 things. The connection has a physical name: quasi-resonant amplification. Wave numbers 5 through 7. Low phase speed Rossby resonance. Mechanically coupled trough configuration. The mechanism is in the peer-reviewed literature. The connection is not hidden. It is simply not built into the communication architecture of the National Weather Service. There is one more piece of context worth holding before closing. When the Kornhuber 2020 paper looked at crop loss numbers associated with wave number 5 and wave number 7 resonant events, regional losses ran to 11% for the worst configurations. 11% does not sound like much on a page. Translate it to food security, and the number changes meaning. The major breadbasket regions of the Northern Hemisphere, the US Midwest, the European Wheat Belt, the Black Sea Grain Corridor, the Chinese North Plain, the Indo-Gangetic Plain, together produce more than half the world's caloric supply from staple grains. An 11% regional reduction in 2 or 3 of those breadbaskets simultaneously in the same year is the kind of supply event the international grain trade was not designed to absorb. We are watching one wave number on one continent. The same kind of pattern can produce concurrent extremes across continents when the resonance is broader. Summer of 2010. Concurrent Russian heat dome and Pakistani monsoon flooding, driven by a single wave number 7 configuration. Summer of 2018. Concurrent extremes across Europe, North America and East Asia, wave number 7 again. Summer of 2022. The same. The patterns are real and they are repeating. So, what do you do with this? The honest answer is, you learn to read the signal before it arrives. Any weather enthusiast can track a 500 millibar chart, troughs and ridges visible as dips and bulges in the wind pattern. When you see a deep trough locked over the western United States and a stubborn ridge anchored over the western Atlantic, and the pattern has been there for more than 4 days with no sign of movement, you know what is coming. Not the specific details, the mechanism. You learn that the heat on the East Coast is not separate from the snow in Wyoming when they are happening on the same calendar day. You learn to think of the country as a connected weather system rather than 50 separate states. The next configuration is already in the data. The first signal will be the position of the Bermuda High and the depth of any new trough digging into the Great Basin. If both come back together, the pattern is loaded again. The cold front arrives Wednesday night.
The pattern resets, the atmosphere goes back to looking quiet, and sometime later this summer, it might be a week, it might be a month, the wave amplifies again. And the next time it does, somewhere a National Weather Service forecaster will sit down before sunrise and write the words, "close to the maximum relative to climatology." Listen for it.